Welcome back, and we're going to look at condensing logarithmic expressions. So just as a reminder, we are in our discussion of logarithmic properties. So we talked about the three biggies. So power rule, quotient to difference, product to sum. And last video we looked at expanding. So that's taking a compact expression, writing it in as multiple logarithms. Now we're going to go in reverse. So we're going to take multiple logarithmic expressions, try and condense it into as few logarithmic expressions as possible. Okay. So again, we are going to try the same process that we saw in the last video. So we're going to try and use the power law, but now in reverse. So instead of looking for exponents, we're looking for coefficients, and coefficients are going to go inside as exponents. Then after that, we're going to try to look for differences and write those as quotients. So again, we're going backwards. And finally, we're going to try to look for sums and write that sum as a product inside the logarithm. Okay, so here we go. Let's get some practice. I'm doing the first one, you're doing the second one. Okay, so we want to condense each expression as much as possible. So this first one, I want to begin by the power law. Okay, so are there coefficients? Yep, there is a coefficient of 1/3. So that's going to go inside as an exponent on x squared. So it would look something like we'd have x squared inside, and then there'd be the 1/3 exponent. You can simplify that in a minute. I'm just kind of illustrating this for now. And log base e. Oh wait, that's the same as natural log. Okay. So, and then if you wanted to simplify this thing, you sure could. X to the 2/3, because when you have exponents on exponents, you multiply them. Okay, moving on. So now I've done the power law once. Now I need to pause, go back. Are there any more powers? Are there any more coefficients? Okay, no. Okay, moving on. Is there a difference? And I'm going in reverse, so I'm looking for a difference and writing that as a quotient. Yep, there is a difference. So then that becomes division inside the logarithm. I cannot stress this enough. It would look like y over x to the 2/3. Okay, do not, and this is a big hazard sign, a lot of students want to say, oh, it's a quotient, that just means we divide. So it's like ln of y over ln of x to the third, or 2/3. Okay, right idea, and you're going to make this mistake at least once. I know it's going to happen. It's okay, but I'm just gonna be patient with you and say, nope, that's not right. We need to fix it. So don't try not to make that mistake. Okay, so division inside the logarithm. Okay, so and then now I need to restart. Okay, so I did the quotient difference. Restart. Are there any more coefficients that I can take into powers? Nope. Are there any more differences that I can take into a quotient? Nope. Is there a sum sum between logs that I can write as a product? No. So I am done. Okay, so great. We solved one. What about the next one? Okay, I want you to try it. Okay, so start with looking for coefficients, write those as exponents. Then, after you've done all those, look for a difference, write that as a quotient inside the logarithm. And then sums, write that as a product inside the logarithm. Okay, pause the video, try it out. So here's my solution. I did the power law first, so I looked and I said, were there any coefficients? Yep, there was a 3 and there was a 4. You could also think of it as a -4. That's okay too. Just if it is -4, make sure to leave a plus there, a sum. So then the 3's came up inside as exponents. So the 3 came up inside as a third power. The 4 came up in as an exponent as 4. So to the fourth. Okay, so then I restart. Power law, are there any more coefficients? Nope. Okay, moving on. Quotient to difference. Okay, is there a difference? Yes, there is a difference here and actually here as well. But I'm going to go slow, so if you can do multiple of these steps at once, hey, great. Just be careful. Sometimes you go too quickly and make errors. So if you do this difference first, that would be x to the third over t to the fourth inside the logarithm. Okay. And we can do that because we have same bases. Both of these are log base 3. Then I ask myself, okay, at the second stage here, are there any more powers? Nope. Are there any more differences? Yes, there is. There is a difference between log base 3 of x to the third over t to the fourth and log base 2 of y. But I cannot combine them because they are different bases. Okay, you need same bases to combine. Okay, so can't do anything more there. So moving on with my life, then okay, no more differences I can resolve. So is there a sum? Yep, there's a sum between these two logarithms. They are the same base, so I can combine them. And I wrote it as 2x to the third in the numerator all over t to the fourth. It would be 2 times x to the third, or x to the third over t to the fourth, and then you can multiply fractions. Okay, and at this point, you can restart the process, but we're effectively done because we have done. There's no more coefficients, or there are no more differences, there are no more sums. So this expression I could condense from 4 logarithmic terms into 2. Sometimes you can do it into 1, but not all the time. Okay, so just be on the lookout for bases, right? We need same bases to combine, and otherwise you have to leave them. Okay, so that's going to be it for this video. So we've looked at properties of logs, how to expand and condense, and now there's one final property that we are introducing last, just because students tend to mix it in with the others, and it's mainly used for evaluation. So this would be when you're going to compute a number. So we'll see that in the next video.